Prior to configuring the transmitter for a boiler drum level application, it will be necessary to know some of the process application data. For this demonstration, we will be configuring the transmitter for a boiler drum level measurement of -15 to +15 inches. The drum pressure will be 150 psi saturated steam, and because this is saturated steam, we will not be using an external RTD, but rather utilizing the IMV31 internal saturated steam table to determine the temperature. Also, prior to configuration, it will be necessary to know the following measurements. The distance from the transmitter to the lower tap on the drum. This will be referred to as the H2 measurement. For this demonstration, the H2 distance is 60 inches. The distance from the transmitter to the upper tap on the drum. This will be referred to as the H3 measurement. For this demonstration, the H3 distance will be 90 inches. The distance from the lower tap to the zero level measurement. This will be referred to as the H1 measurement. Typically, in a drum level application, this is the midpoint of the drum. For this demonstration, the H1 distance is 15 inches. In order to fully configure the IMV31 transmitter, PCMV software must be used. The latest version of PCMV can be downloaded from the Foxboro website. Once the transmitter has been physically connected to a computer by way of the proper HART modem, we can begin the configuration. From the desktop, double-click on the PCMV icon. From the Device Operations menu, click on Connect to Device. The Connection Details dialog box will be displayed. Select HART Protocol and select the communication port to which the HART modem is connected. Once the proper selections have been made, click on OK. The polling address dialog box will now be displayed. If the transmitter is being used in 4 to 20 milliamp output mode, select poll address 0 and click OK. A dialog box will then appear to verify the device tag number. Click Yes to connect to the transmitter. Once the transmitter is connected, click on the device configuration icon and wait for the level configuration screen to be displayed. The first tab to be displayed is the Identification tab. This allows entry of information to uniquely identify the transmitter. In the Company ID field, enter the company name. In the Tag field, enter the device tag number. The maximum number of characters that can be entered in this field is 8. The descriptor field allows entry of up to 16 characters, and the message field allows up to 32 characters. Information entered here is informational only and is completely optional. The local display password provides password protection from changes being made to the device via the push buttons on the local LCD display. Available selections are No Password Protection, configuration only will be password protected, or both configuration and calibration will be password protected. Once all selections have been made, click on the Next tab button and General Configuration will be displayed. The first field to be configured is Preambles. A preamble is a signal used to synchronize transmission timing. Currently, all newer devices implement 5-byte preamble. Anything greater reduces the communication speed. The polling address can be assigned for any value from 0 through 15. If a 4 to 20 milliamp output is required, select a polling address of 0. Selecting a polling address other than 0 will lock the output at 4 milliamps. Milliamp output failsafe allows the selection of the output value if the device were to fail. Upscale will provide a 21 milliamp output and downscale will provide a 3.6 milliamp output in the event of a failure. PV is the primary variable. This is the measurement that will drive the 4 to 20 milliamp output. For this variable, select M6 level. SV, TV, and fourth variable are only transmitted via the heart signal and have no effect on the 4 to 20 milliamp output. Once all selections have been made, click on Next tab and the differential pressure configuration will be displayed. Select the desired differential pressure engineering units, then click on Next tab to go to the absolute pressure configuration. Select whether the measurement is to be absolute or gauge pressure, and then select the desired pressure engineering unit. After the appropriate selections have been made, click Next tab to go to the temperature configuration. Select the desired temperature engineering units. The RTD is not being used because this is a saturated steam application. However, notice that the RTD on selection cannot be deactivated at this time. This is due to the fact that the transmitter has not yet been configured for a boiler drum application. This will be deactivated at a later time. Once all necessary selections have been made, click Next tab to go to the level measurement configuration. Select the desired tank dimensional units and level engineering units along with the lower and upper range values. These values are the values that will determine the 4 to 20 milliamp output. Once all selections have been entered, click Next tab and the density configuration will be displayed. Select the desired density engineering units and click OK. The screen will now become blank. Click on the Edit Application Design Conditions icon. This will open the tank level configuration screen. In the tank type field, select Boiler Drum. Double-click on the yellow rectangle surrounding the H1 measurement and a dialog box will appear. This is where we enter the applicable H1, H2, and H3 dimensions. In this specific demonstration, H1 equals 15 inches, H2 equals 60 inches, and H3 equals 90 inches. Once all the values have been entered, click OK. At this point, scroll down to the operating conditions. This is where we set limits for our level calculation. The transmitter will only correctly calculate level when the pressure and temperatures are between the values we enter here. The first parameter to be edited is M2, which is our boiler drum pressure. In this demonstration, our normal drum pressure is 150 psi. Because we want the transmitter to continue to calculate level even if we go above 150 psi, we will set the M1 limits to 0 and 200 psi. Because we are not using an RTD, we will select a T1 source of saturation temperature. T1 is the temperature of the water in the drum. At 200 psi, the water temperature should not exceed 400 degrees F, and under shutdown conditions, the water temperature should not go below the ambient air temperature. Therefore, we will set the limits to 60 and 400 degrees F. T2 is the temperature of the water in the lower leg. Select electronics temperature as the measurement source and set the limits to the expected ambient air temperature limits. In this demonstration, we will use 60 and 150 degrees. T4 is the measurement of the water in the upper leg. Select sensor temperature as the measurement source and set the limits to the expected ambient air temperature limits. In this demonstration, we will use 60 and 150 degrees F. Once all selections have been entered, click OK, and the drum water properties screen will be displayed. Enter the normal operating drum pressure, then click OK. The saturation temperature at that pressure will automatically be calculated and displayed. Click the next button and the drum water density at normal operating pressure will be displayed. Click the Save button and the steam density at the normal operating pressure will be displayed. Click the Save button and the upper leg water properties screen will be displayed. Enter the normal upper leg water temperature. Click the next button and the upper leg water density at the normal operating pressure will be displayed. Click Save and the Save Level Configuration dialog box will appear. Click Yes and a warning will appear indicating that the transmitter output will be modified during the save function. Click OK and wait for download to complete. This may take several seconds. Once the database has been downloaded, a dialog box will be displayed indicating that changes to the device have been completed. Click OK and a message will appear indicating that the download is complete. Click OK and the screen will become blank. Click on the device configuration icon and the level configuration screen will be displayed. Click on the temperature tab and the temperature configuration will be displayed. Remove the check mark from the RTD on box. Click OK and the screen will become blank. From the Device Operations menu, click on Disconnect from Device and a dialog box will appear asking if you wish to connect to another device. Click No and the transmitter is now ready for installation into the process.